Well, good morning, everybody. Hopefully I'm sharing the right screen now. My name is Scott Fowler, and we're going to be going over a sneak peek of what's coming in TechPlot 360 2020 R2. This release is due out in December of this year, and we have a beta available now for you to test and give us feedback on. We're about 6 weeks away from release and are eager to get feedback and happy to give you a preview of what's coming and give you a chance to try it before it's officially released. You can see here, this beta is going to be available, well, it is available now. If you log into my.techplot.com, you do need an account there to download the bits. The presenters today, myself, I'm Scott Fowler. I'm the product manager at TechPlot, so I'm responsible for TechPlot 360, Tecplot Chorus, our TechIO library, and TechPlot Focus, PyTechplot. So most of the products that you're using or maybe using in your workflows. We're also joined by Devin Simpson, technical product engineer. Devin helps me tremendously in the everyday work, and she'll be on hand to answer questions. So if you do have questions during today's webinar, please type them in the question and answer pane in GoToWebinar, and we'll be sure to get to those. At the end of the webinar, we'll take questions as well. So if you do have questions, make sure to type them in there. Okay, so we may have a few people here who are new to TechPlot, so I'll just briefly go over who TechPlot is. Just to remind you, for the people who have been around and for those that haven't. We were founded in 1981 by a couple of Boeing engineers who were writing CFD codes at the time, and they needed a way to visualize their results. So they hired an engineer who's still at TechPlot today to build TechPlot. And since that time, we've become one of the biggest post-processing, dedicated post-processors around with 47,000 customers worldwide. We're known as the most complete desktop solution because we have not only great 3D plots like you see here, but good XY and 2D plotting, even polar plotting if you have polar line data. And we're really dedicated to saving engineers time. You know, we really see that there are three main problems that need to be addressed in the post-processing world. One is data is getting larger with Moore's law. So we've developed a new file format for that called SIZL, Subzone Load on Demand. Loads less data, uses less RAM, and you get your data loaded faster. We also have Tecplot Chorus to help you understand ensembles and design of experiments. We'll go over Tecplot Chorus today because we're reintroducing it with this release. It was left out of the 2020 R1 release because it wasn't quite ready after doing a big port of our user interface. And then automation. You need to get work done while you're sleeping. You need to get work done automatically, and that's where our Python language comes in and our Tecplot macro language. Okay, so what are we going to be going over today? We're going to go over the 4 main features that are in this new release, in this beta. We're going to reintroduce Tecplot Chorus, and I'll give a brief demo of the Tecplot Chorus product to give you an update of what it is and why you may want to use it. We'll talk about referencing variables by name. This is really important if you have data sets that have that you've run, say, maybe with different solvers that have the same variable names, or maybe you just exported a file with a different variable set, but it's really the same data set and you're trying to compare multiple. We'll give a demonstration of that. Talk about CGNS 4, why it's important and what we did, and then calculating variables up to 11 times faster depending on your data type and the number of cores on your machine. We'll talk about the work we did there. Okay, so Tecplot Chorus. Again, Chorus is really used for exploring arrow databases, results from DOEs, ensembles of data, and it gives you a nice unified environment to look at all of this information. So instead of looking at each individual file, which Tecplot 360 is great at, this helps give you an overview of all the data that you're looking at. In 2020 R1, we updated Tecplot 360 to a new GUI toolkit called Qt5. We were using Qt4. Qt5 gave us better experience on high resolution displays, 4K displays, 5K displays, And when we made that port, Tecplot Chorus wasn't quite ready to go, so we held it back. Now this is the reintroduction. So it's going to be compatible with the newest version of Tecplot 360, and you can find all sorts of information there. So let me bring Tecplot Chorus into the view and show you what it can do. So Tecplot Chorus, what we're looking at here is a small aero database. We did a number of simulations of a vehicle, and we varied Mach, alpha, and beta. So those are our inputs. Our outputs were the number of iterations that it took for this solution to converge, and then lift, drag, and pitching moment as the outputs. So the input to Tecplot Chorus is a simple CSV file. Let me just drag a CSV file over here to show you what that looks like. So very simply, we created a CSV file that has all of our inputs. We call those variables independent. All of our outputs, we call those variables dependent, and data files that we wanted to, data files and image files that we wanted to associate with this project, and we call those aux files. So you can see pretty easy input deck to Tecplot Chorus. Okay, so what can you do with Tecplot Chorus? Well, you have your table view, which you can see all of the inputs and outputs quite easily. You can create 3D plots here. And in this 3D plot, we're looking at Mach and alpha on our X and Y axes and drag on our Z axis. One of the really neat things about the 3D axes is you can actually do a surrogate model to look at the system performance or predicted system performance. So what we're looking at here is we're looking at all of the scatter symbols across all of our beta values, but because beta is not one of the axis values, this surface that you see behind it is at a specific beta. So that's at beta 0. If we go up to, say, beta 16, you can see this curve changes. And if we look at just the points that were simulated at beta 16, we only have a few points, but then we have predicted performance for beta 16 across the range of alpha and Mach. So the surrogate models are a pretty neat capability. You can see that the filters, I'm able to change the filter type. So here I just wanted to do a single value filter, and you see that that applies to all of my views. So my 2D scatter view here changed. The table view also updated, so you can see that red signifies values that are violating a filter constraint. So the filters are pretty handy to be able to narrow down data. Like, let's say here I wanted to focus in on items with high drag. I can look at those quite easily, highlight them, and pretty easily compare. You can see in the table view, all of my selections are pretty well scattered about. So we have this nice selected cases view down here to show just the few cases that I've highlighted here, and you can see that all of these pass my filter. We have a little indication here showing that this column is filtered. So nice capability to look at those. Now, if we want to see the data that's behind this or the images that are behind this, I can simply right-click and say View Images, and this gives me a view of all of the images that are available for those selected points. We can even dive right down into the raw data. So let me select just a couple of items here, and if I right click, I'll say View Data. And this is going to allow us to launch Tecplot 360. So if I just hit OK, this is going to load actually the data behind this, the raw data, in Tecplot 360, so we can get a deeper view of what's going on with these two cases. It just takes a little while for Tecplot 360 to launch. And now we have these two data sets side by side. You can see that this also creates a special custom Tecplot Chorus sidebar with some additional capabilities. So if we want to identify these a little bit easier, we can put Mach, alpha, beta right on there. Let's look at the drag coefficient. And these two are immediately synced, so I can look at these two data sets side by side. I can also compute a diff between these two, so sometimes it can be hard to, if the contours are quite close to each other, it can be hard to see what the delta is. And now this is a delta of the variable that we're contouring by. And let's say also we wanted to get an idea of a different view of the data. So let's say we want to see the underside and in a different color map. Let's use a diverging. Okay, you see this only affected this plot. Well, I can say synchronize styles, so that synchronizes across the top. When I'm in this diff view, if I had other cases loaded and this were the primary frame, I could say synchronize styles and it would synchronize others down here. Let's say I like this view and I want to apply this to my project back in Chorus. Let's save this style template. You know, in TechPlot parlance, this would be a style sheet. So we'll save this as bottom view. I already have one here. I'm just going to overwrite this. And then let's go back to TechPlot Chorus. And I will reset my filters here. So we can see all of our views. And if I go up here to my matrix view, you can see I only have one image, but I now want that bottom view image as part of my project. So let's select this for just a few runs, and I can say create images, and we'll say I want to use this style template, this bottom view style template, and I'll hit OK, and this is going to go off and it's going to start running a job. Now I've already run one of these, so kind of like in the cooking shows, I have a job already completed. So one's in the oven, one's coming out. So let's just deposit this job that I already ran. I'm going to call the new images contour data bottom view. We'll hit finish. And then if I go back over here to my matrix view, I now have that bottom view data. You can see that a couple of these are a different angle. This is the one that I'm currently running. So some of those images got overwritten during the run, so that's why it's a little bit different. But you can see that you can now use TechPlot Chorus in conjunction with TechPlot 360 to create new attributes with your data. You can dive down into your data using TechPlot 360, and you can see a lot about the overall system performance. So pretty interesting tool with TechPlot Chorus. We have a lot of how-to videos available on the TechPlot 360 website, or the TechPlot website, sorry. And please do check out the website. I think this is a really great tool for looking at a lot of big collection of data. All right, so TechPlot 360 itself, we've added a new capability to reference variables by name. So why is this important? Well, sometimes you have two simulations that you've run, and say one simulation, you export more variables than another. Let's say you had chemistry on versus chemistry off, and maybe the position of the temperature variable moves from variable number 5 to variable number 8. Well, you're going to get a plot that if you're trying to reuse a layout or a style sheet, or even a macro, your layout file or your script might not work right if you're using variable numbers. So we've added the ability to use names for variable assignments. This is not on by default, so you have to activate this. This is available in the TechPlot configuration file. And let me just bring up Notepad++, and I'll show you where that is in the configuration file. So in this beta, when you install it, you open the techplot.cfg file, which is in the main directory when you install. And there's this line 40, it's commented out right now because the default is off. All you have to do is uncomment this line, and you're able to then have variables by name referenced in your layouts and style sheets. Another option is to put it in your techplot.mcr file so you can turn it on and off quickly. It's better if you have it in your config file, but for the demonstration that I'm going to show today, I'm using it from the TechPlot quick macro file. Okay, so let's show this in action. I'll just bring over TechPlot 360 here, and here I have a data set. This is a converged data set. of a diesel cylinder. It's 1/6 of a diesel cylinder. And if I look at the dataset information dialog, you can see that what I'm coloring by NOx, which is variable number 12. And what I want to do is I want to apply this same style to a new data set. So let's create a new frame and load a different data set that I want to compare against. Now this one is called, this data set was called all variables. And if we look at the data set information dialog, you can see that NOx is way down here at variable number 25. So variable numbers are not going to work properly. And let me demonstrate this. So if I go to frame, and I'm going to save the frame style, and we'll save it at NOx by num. Yes, I want to save it, and then we'll load that frame style, NOx by num. You can see I didn't get the right plot, and that's because, again, that style sheet saved the variable by number. It was variable number 12. Let's just verify that. If we go into dataset info, NOx is variable number 12, but in this data set, 12 is equivalency ratio. So we got the right plot by variable number, but we really want it to be correct by name. So let's go back over here, and we'll say use names for variable numbers. So I'll just double click, and that will turn this new capability on. Instead of going through the menu, I also have a quick macro to save the frame style. So I'll just double click this, save the frame style, and then we'll load it back in over here. And you can see now I have the correct plot because variables were referenced by name. So if you're in this situation where you have data sets that have variables that move around in different positions but share the same name, this is going to be a nice feature for you. And we're going to be moving more towards a name-based access for zones and for variables. Find that for people who are doing data set comparisons, it just seems to work better. One caveat here, though, is if you do have duplicate variable names, which we've seen in some data sets, like you might have multiple sets of vector variables, UVW, and then another set of UVW, it's going to pick the first variable in the list. So, and that's going to be the first one that it encounters in that numeric order. So you might not want to activate this if you do have duplicate variable names. We haven't seen a lot of people in that situation, though, so this should work pretty robustly for you. Okay, next capability is CGNS 4. Why should you use CGNS 4? Well, CGNS 4 added better parallel write performance for polyhedral data. So keep in mind, Tecplot 360 doesn't write CGNS. We don't write in parallel, but some of you may have CFD codes that do write in parallel. And if you have polyhedral data, you'll probably want to update to CGNS 4 if you haven't already. So Tecplot 360 now adds support for reading those files. They did change the file format slightly, and that's why we needed to update our loader. We have found through this project that HDF5 backed CGNS files offer better performance when we're reading it in. So if you have an old ADF backed CGNS file, you can convert it to HDF using one of the CGNS utilities, and you're going to get better performance, particularly on Linux. We've found the Windows performance is about the same. We also found that there is at least one combination of the CGNS library and the HDF library that is no longer supported in CGNS 4. And we brought this up with the CGNS community. They're aware of this issue and have a bug that they're tracking against it. But for now, if you are using CGNS with HDF5, prefer using CGNS 3.3 with HDF5 1.8 or CGNS 4 with HDF5 1.12, and you'll get the best results. Okay, and now on to updating some of our variable calculations. We added multi-threading or additional multi-threading to calculations. This dialog that you see here, this is available under the Analyze menu, Analyze, Calculate Variables, and all of these functions now that you see, Q criterion, vorticity, magnitude, etc., are going to be fully multi-threaded. And so what do I mean by that? Well, in previous versions of Tecplot 360, we were multi-threaded only when you had Calculate on Demand on and only if you had multiple zones. We would thread over zones, but not within a zone. So if you're in the situation where you weren't using Calculate on Demand for some reason, or you had just a single volume grid, you're going to get a big boost in performance, as you can see in this number, up to 11 times faster. Now that was done on a 32-core Windows machine, computing Q criterion with a data set that was 8.6 million polyhedrals. So let's just show this video as a demonstration. So what we've done is we've clicked on a layout, which is going to open this 8.6 million element polyhedral data set. It's going to compute Q criterion and generate the isosurface. You can see immediately in 2020 R2, the beta that you're going to be able to download, we're using all 8 cores here for that computation. Whereas down here in 2020 R1, we're effectively using just one CPU core. These top 2 tend to get used. Now we've sped up this animation 20 times because we don't want to sit here and wait 5 minutes for this to complete. So 2020 R1 took 284 seconds in this case. It's about 8 times faster here. Now this was on an 8-core machine. The 11 times faster is on a 32-core machine. So not perfect scaling with the number of cores, but a big speed improvement. So how does this work with different data sets? So yes, the one big polyhedral zone data set, we got a huge speed improvement on that 32-core machine, 11.6 times faster. With an open foam data set, 66 total zones spread over 11 zones, 6 time steps, so 66 total zones, 27 million total elements, finite element brick. We got a 1.3x speed improvement. So like I said, we were already multi-threaded over zones. So you got you definitely had some speed there, but we've improved it, by about 30% here by threading within a zone as well. And then we have also a plot 3D data set. We did one with 10 zones, structured grid, and 160 million total elements. We went from 731 seconds down to 344 seconds for about a 2.1x speed improvement. And all 3 of these data sets, we were doing effectively the same thing: loading the data, computing Q criterion, creating an isosurface, and then exporting that to an image. So certainly loading of the data is a large part of this, but all of this was, we ran each one of these tests 3 times. And by that 3rd time, the data is pretty well cached in the memory of the hard drive. So the data loading is a pretty small component of this at that point. When you're loading a very fresh data set that has just been created or loading it for the first time, the load time is going to have a greater effect on total runtime. So we're really happy about these speed improvements, particularly for those of you that have large zones. So that's going to be, users of Converge. We've seen a lot of fun 3D data sets that are one large grid. So it's going to be a big improvement for that crowd. Okay, so those are the main capabilities that are in this beta. So what's coming up next between now and the actual release date in December? We're going to be adding support for Converge 3.1 file support. Our understanding is Converge 3.1 is going to be available around the turn of the year, but we're going to get our data loader ready for those Converge users. They're adding solid, liquid, and gas particles to the 3.1 file format, so we'll be ready for that. And then Fluent HDF5 support. This has been requested by a number of people. Now, the schedule is looking like we're not going to be able to get it into that December release, but we're going to be working on it. Work is starting on it fairly soon. It usually takes us about a month and a half to 2 months to get a loader from scratch to new. And this HDF5 format, we can't just update our existing Fluent loader. The format's changed enough, so we're going to be introducing a new loader for that ANSYS Fluent CFF format, which is based on HDF5. So if you are somebody who is using this format, please contact us. We've had a number of people already contact us, and we'll be working with you to develop this loader and test it as we go, so we can get you unstuck on your work so you can use TechPlot 360 for your Fluent data. We also have various bug fixes and a couple other improvements coming down the line, so please keep an eye out for that December release. Again, you can download it here on our website. And I'd like to invite you to our next webinar. Last month we did a webinar on Tecplot for loading XY line data. If you don't have a data loader built into Tecplot, you can use Tecplot to actually load your data, which is a really neat capability. So we're going to be extending that webinar, going and looking at loading of 2D and 3D structured data with Tecplot. It should be a really interesting webinar. It's kind of fun. We're using Jupyter notebooks to integrate with Tecplot 360. It's pretty fun. So please keep an eye out for that. And if you can take the time to review the previous webinar, that would be a good prerequisite for this one. So with that, I'd like to open it up to any questions you may have about Tecplot 360, any comments about capabilities that you'd like to see that maybe we're missing. You can always see various tutorials on our website, tecplot.com/videos. We have training, so if you're new to Tecplot, you can get up to speed with that training link. And you can always contact our support staff. North America, support@tecplot.com, Europe and Western Asia, support-EU@tecplot.com. And if you're outside of those two regions, we do have local distributors in various countries and regions around the world. And so you can find out your local distributor. It's often easier to work with them because they're in your time zone. So tecplot.com/distributors. So that, we'll open it up to questions and we'll stay on the line for a few more minutes. Thank you. Oh, it looks like one question did just come in. Yeah, so it says, I saw you said Tecplot now can support HDF5 files. Is that compatible with export from ANSYS? So the answer is not yet. We're working on it. So the Fluent HDF5 format is a brand new format. It takes us about 6 weeks to 8 weeks to develop a brand new loader, and that's what's going to be happening here. Our scheduled release is for early December. We should have a beta quality loader available in the December timeframe, but it's not going to make it into the release. So if you haven't requested the Fluent HDF5 format from us already, please contact support@tecplot.com and we'll get you on our list of requesters so we can work with you on that format. Okay, well, thank you very much for your time today. I appreciate it. Again, contact us anytime. We're here to help and happy to interact with you. Bye-bye.